Today we're going to talk about solving polynomial equations in factored form. So let's first take a look at the difference between a factored form and standard form polynomial. So here's factored form, 2x times x plus 3. That is considered factored form. If I were to expand that and get 2x squared plus 6x, that would be considered standard form. Let's try another one of those examples. X plus 3, x minus 2. And if you take a look at that, that is considered factored form. If I were to expand that and get x squared minus 2x plus 3x minus 6, and then simplify that to x squared plus 1x minus 6, that would be what it looks like in standard form. Over the past couple of days, we have taken I just dropped my calculator. Over the past couple of days, we have taken and looked at how to go from factored form into standard form. So how to distribute, expand, multiply through. Today we're going to go the other way. We are going to go from standard form over to factored form. And we are actually going to take about the next 4 to 5 days to talk about all the different cases that go from standard form to factored form. So the first word we hear about is the word called roots. The roots are really just your solutions. So another name for roots are your solutions or your answers. And I'll kind of explain what that means coming up here as well. The next key word is zero product property. And that's just a property that we use to solve. It's a property to solve the polynomial equation. Now, let me explain a little bit about this property. So if I gave you a times b equals 0, you could tell me that if a is 0, b could be anything, and you would still get 0. So b could be any number. Or you could say b could be 0, and a could be any number, and it would still work. But I need one or both of them to be 0 in order to get that to work. So if I gave you this, you could give me a solution where a is 3 and b is 0. You could also give me a solution where a is 0 and b is 7, but one of them would have to be 0. That is called your zero product property. And then we have these things called repeated roots. That is when 2 or more roots of an equation are the same number. And those are called your repeated roots. And I'll explain to you a little more of what that means coming up. So what we're going to do first is we are going to use this zero product property to actually get some different values when solving things. So if you kind of think about the zero product property, if we're going to solve this and it's equal to 0, we know that either this part has to equal 0 or that part has to equal 0. So out front is just an x. So if x was 0, I would get 0. Or if x plus 5 equaled 0, I could also get 0. So what I'm doing is I'm taking my first chunk and setting it equal to 0, and I'm taking my other chunk and setting it equal to 0, and I'm solving this. So the way I solve this is I subtract 5, and I get x equal to negative 5. So my two ways of solving this, x could either be 0 or x could be negative 5, and that would get me a solution of 0. So let's try another one. So what you do is you take your part outside and you set that equal to 0. And then you take your other part and set that equal to 0. And then I solve them both. If I divide by 5, I get p equal to 0. If I add 2, I get p equal to 2. And those are going to be my two solutions. Those are called my roots. They would be repeated roots if they ended up being the same number. So let's try another one. If you notice, these were monomials and binomials. Now I'm talking about a binomial and a binomial. I still do it the same way. I take my first piece out front there, set that equal to 0, and then I take my other piece and set that equal to 0. I add 2, and I get c equal to 2. I subtract 1, I get c equal to -1, and those are my two roots or zeros or solutions. Okay, let's try one more, and then we're going to talk about maybe a pattern. So in this case, I would take 2b minus 6 equal to 0, and I would take 3b plus 18 equal to 0, and I would solve them. I would add 6, get 2b equals 6, divide by 2. So my first solution is b equal to 3. Over here I would subtract 18. I get 3b equal -18. I would divide by 3, and I would get b equal to -6. And those are my two solutions. Now, as we do more of these, you may start to see some patterns. So for example, whenever there is a variable out front, and either a variable or a number multiplied by that variable, you're always going to have the 0 of 0. Whenever you see a number inside with the variable, you just change the sign of that. So this would be 0, -5, 0, 2, 2, -1. It's a little bit trickier when you have a number in front of the variable. So the shortcut way of doing the number in front of the variable is just like we took the opposite here. You take the opposite of -6 and get 6, but if there's a number out front, you divide by that number, and that's how you get the shortcut way of getting 3. So in this case, you would take -18 and divide it by 3, and that's where I get the -6. So if you like how we did all of these the long way, you are welcome to set each part equal to 0 and solve. There is a shortcut way. So for the rest of them, I'm going to do the shortcut way. So in this case, I take the opposite of that number, -7, and if there's a number in front, I divide by the 3. That's my first solution. Opposite of -6 is 6, and I divide by the 5. And those are my two answers. In this case, you see how there's a power of 3? That actually means there are 3 of them. However, if I write it out 3 times, my 0 here is the opposite of -3, which is 3, and then 3, and then 3. That's called a repeated root because it happened more than once. And that's my only answer because I only have to write it down 1 time. Over here, I take the opposite of 4, and I get -4, not a number to divide by. I take the opposite of +1, I get -1, no number to divide by, and I am finished. In this case, there's a variable out front. Anytime there's a variable or a number multiplied by that variable, it's a 0. To do the shortcut here, I take the opposite of 6, which is -6, and I divide that by -3. The shortcut here, I take the opposite of 6, which is -6, and I divide that by +3. And then I simplify them. So I have 0, +2, -2. This one will be the hardest one because it deals a lot with fractions and negatives. So in this case, I take the opposite of 4, which is -4, but there's a number in front here other than 1. It's actually a -1, so I divide by a -1. I take the opposite of 8 and get -8, and I divide that by 2/3. I take the opposite of -2, and I get 2, and I divide that by -3. So now, this first one is easy to simplify. I get 4. The next one, you can just take -8 and divide it by 2/3 on your calculator. I get -12, and then my last one is -2/3. And that is the shortcut way. If you didn't like the shortcut way, you could take that, set it equal to 0 and solve, take that, set it equal to 0 and solve, and then take this, set it equal to 0 and solve. All right, on the next page, we're going to talk about factoring and solving. So now we're going to talk about how to go from standard form to factored form. And we're going to talk about this thing called the greatest common factor. So the greatest common factor is the number that goes into each of my two pieces, and it's the biggest number. So say I have 32, and say I have the number 20. If I listed all the factors of 32, 1 times 32, 2 times 16, 3 doesn't work, 4 times 8, 5, 6 doesn't work, 7. All right, so I got them all. If I listed all my factors of 20, I would have 1 and 20, 2 and 10. I would have 3 doesn't work, 4 times 5, and those are all my factors. So then what I do is I try and find the biggest one they have in common. So they have 1s in common, 2s in common, 4s in common. So my biggest one of those is 4. So my greatest common factor would be 4. So that's what we're going to use today to factor some of these. So let me rephrase on kind of what factoring is. Factoring is, instead of going from this to this, factoring is going from this to this. So it's kind of undoing distributing. And that's how we're going to do factoring today. So this is how you do it with numbers. With variables, it's a little bit different. You have to kind of think about this as there are 2 k's over here and 1 k over here. And I have to pull out the most k's from each bucket. So there's no way I could pull out 2 because he only has 1. So I can only pull out 1 k from each kind of bucket in order to have enough to pull out. Hopefully that will make a little bit more sense right here. So the first example, you have a 6 and a 1. There is not a number that goes into 6 and 1 bigger than 1. So you don't have to worry about pulling out a number. But you have a k squared and a k. So you are going to pull out the least amount of k's between the two. So he has 2 and he has 1, so I can pull out just a k. And then you have to kind of undo distributing. So what times k is 6k squared? Well, this is kind of like a 1k. So 1 times 6 is 6. K times k is k squared. And then you say, okay, what times 1k is 1k? The number 1. The way you know you're right is if you distribute. This turns into 6k squared plus 1k. Did I get back what I started with? Yes. Once I factor, I then can solve, which is what we just did on the other page. There's a variable out front, so k equals 0. I take the opposite of 1 and get negative 1, and then I put the 6 underneath, and those are my solutions. So I have to factor and get the solutions. Let's try another one. In this case, the biggest number that goes into both of those is 7, and I can pull out an n. I cannot pull out any more n's because he only has 1. So then I say, what times 7 is 35? And I get 5. I already have my n, so I don't need anything else there. And then what times 7 is negative 49? And I put a negative 7. I have an n, but I need an n squared, so I need 1 more n. And if you want to know if you're right, distribute. 35n minus 49n squared, it matches what I started with, so I know I did it right. Then I get my solutions. The variable out front gives me a solution of 0. Then I take the opposite of 5 and get negative 5. I put it over a negative 7, and my solution is 0 and 5/7. Let's look at my next one. I can pull out a 4. 4 goes into both of them evenly, and I can pull out a z. So from here to here, my 4's are the same, but I need another z. From here to here, and if you can't do that in your head, you can just divide the 2 and say, oh yeah, 52 divided by 4 is 13. I don't need a z because I have 1 out front already. So there's my factored form. Once it's in factored form, check it. 4z squared plus 52z, it matches, I'm good. Then I get my zeros. The 0 out front is 0. Inside I go opposite of plus 13 is negative 13, nothing to divide by, and I am done. If you notice, all of these had all your variables on the same side. This one doesn't. So if the variables are not on the same side, you have to get them on the same side so it equals 0. Anytime you cross over the equal sign, what that does is it just changes the sign of what you're bringing over. So when I bring over the negative 72, he turns into a positive 72x. So now, I look at what's the biggest number that goes into both of those. That's 6 goes into both of those. I pull out an x. I have this, I need this, I'm missing an x. What times 6 is 72? And that's a 12, and I don't need an x because I already have one. So then you check, 6x squared plus 72x. Then I get my two zeros. That has a 0 of 0. The opposite of 12 is a negative 12, and I am done. Let's try the next one. This time, I'm going to keep my squared a positive and bring my 22 over to the other side, and when I do that, he becomes a negative. So the greatest common factor that goes into 11 and 22 is 11, and I can pull out an s. From here to here, I'm missing an s. From here to here, 11 times what is a negative 22, and that's a negative 2, and then I don't need an s because I already have one out front. To check, this turns into 11s squared minus 22s. Now I get my zeros. That 0 is 0. That 0, the opposite of negative 2, is positive 2, and I am done. On my next example, I'm first going to bring the 21p to the other side, and when I bring him over, he becomes a negative. If you can see, both a 7 goes into both of those, and I can pull out a p. From here to here, I'm missing a p. 7 times negative 3 gets me negative 21. I already have my p, so I am done with that. Check it, 7p squared minus 21p. I then have to get my zeros. The 0 out front is 0. The opposite of negative 3 is positive 3, and I am done. On my next example, a boy kicks a ball in the air. The height in feet above the ground of the ball is modeled by this right here, where x is your time in seconds, and y was your height in feet. Find the roots of the equation when y equals 0 and explain what that means. So if y equals 0, that means your height is 0. So you're trying to figure out where the boy hits the ball or kicks the ball, you're trying to figure out when it comes back down on the ground. So this is kind of what our graph looks like. He kicks the ball here, it goes up, it comes back down. We're trying to find how long it's in the air and when it's back on the ground, and that's what this means right here. So I'm going to plug in 0 for my y, and I'm going to factor this. So if you take a look, if you ever have a negative in front of the x squared, you will want to try and pull out a negative. So the first kind of way I always check is I always say, does this number go into the 80 evenly? So if I divide the two, I will quickly see that 16 goes into both of them. So I'm going to pull out a negative 16 and an x. And when I do that, this and this are almost the same except I'm missing an x. And then, if you can't do this in your head, if you just take 80 and divide it by negative 16, you will see that this times negative 5 gets me to the 80, and I already have my x. So if I were to distribute this, I would get negative 16x squared plus 80x. Now to get my zeros, that gets me a 0 of 0. That gets me a 0 of 5, opposite of negative 5, and that is actually my answer. So if you look, the boy kicks the ball at 0 seconds, and that occurs right here when he kicks it, and it's back on the ground 5 seconds later. And those are kind of your two answers. On our last example, we have this equation already in factored form, so we don't have to factor it, but it's the arch of a fireplace where x and y are measured in inches, and the x-axis is the floor. So here's my fireplace with my nice fire inside. Find the width. So if you see, the width is going to be from here to here. So if we can find this point and this point, we can find out how wide it is. The way we're going to get those points is by getting my zeros. There's no variable out front, so we don't have to worry about him, but the opposite of 18 is negative 18, and the opposite of negative 18 is positive 18. So if you take a look here, those just gave me my x values. So this point is 18, 0. This point is negative 18, 0. And if you look, those are 36 inches apart, and that is my width. From negative 18 to 0 is 18. From 0 to 18 is 18. If I add the two, I get 36. Now the height occurs right up here. So the height is actually at this nice peak, and if you notice, that falls right on my y-axis. So that height is going to be 0 something. So the way I get this something is I take, and I'm going to plug in 0 into my equation for x. So I have negative 1/9, and then I'm going to go 0 plus 18, and then 0 minus 18. And when I punch that out, my height then is going to be 36, which is actually the same as my width right now. And you can also double check to see if that occurs right around 36.